Hello everyone, let's solve some Leetcode today. So today we have Leetcode 424, that is longest repeating character replacement. In this question you will have a string s and an integer k. Here you can choose any character of the string and change it to any other uppercase English characters. What this is saying is that we will only have uppercase English character in the string, and we can have multiple types of characters, and we can change any of those character into any other uppercase character. Now you can perform this operation at most k times. It means the replacement operation of taking a character and changing it into some other character can be done only k times. That's what this integer is for. Now we have to return the length of the longest substring that contains the same letter you can get after performing the above operation. Okay, so we have a string like A, B, A, B. Now we have to tell us the longest substring that can have the same characters after we perform the k replacement operations. Here we have two characters A and B. So the frequency for A is 2 and the frequency for B is also 2. And the K is 2. That means we can perform two replacement operations. So we can perform replacement operation on these A or on these B's. So I can replace all the A's with B's, that will give us B, B, B and B string, or I can replace all the B's with A's. So I will have 4 A's in the string. And these are going to be the longest strings that we can get after performing the k replacement operations, and the length is 4, so we will simply return 4. We do not really care about which character we have, we only care that all of them needs to be same in the substring. That's all. So how can we solve this question? One way is to just get all the substring for this particular string and then just simply check if you can actually make all the characters in that substring same or not with the help of given key operations. So suppose that we take this substring from B to B and the k is 2, so we can perform two replacement operation at max. So if I look here, then we have B, B and B. Now I can do replacement on C and X to make this entire string B. So if I replace C with B and X with B, then this entire string will have the same character and the length will be 5. In the same way, we can take other strings also and then check if we can actually make them same character or not. So there are n square possible substring for any given string, and then we will also use a loop to check if this particular string can be turned into a string of same characters. So that will take order of n, so that will take around order of n cube. So this will be the time complexity for brute force, which is not going to be very optimal. So how can we do better? Well, first of all, let us take this particular section and we will try to understand what exactly we are going to do. Now, since we are dealing with string and we have to deal with substring, that is finding the substring and checking if they are valid or not, we can use something like sliding window, right? But in order to use sliding window, we need to figure out what is the valid condition. How can you say whether a particular substring is valid or not? Now, the condition for a particular substring to be valid is that if that string can be converted into a string of same character, that means that string is valid. Here we can convert this particular string into the string of only B's by replacing these two, right? That's why we can say that this particular substring is a valid substring. So how we can check that thing? Well, first of all, notice that we are never going to replace B. Why? Because B occurs most number of times. The B occurs 3 times here, right? And C occurs only 1 time, X occurs only 1 time. So if we try to replace the B, it will never give us a string that will have same characters. It means we need to store the occurrence of a particular character in a substring. So we will have something like a hash map here. And here we can store that the B occurs 3 times, C occurs 1 time, and X occurs 1 time. Okay, great. Now this particular window will have some length, right? Let's just call it a window length. Now I can use this hash map to figure out the character that have the maximum frequency, right? So I see that the character with the maximum frequency is B. So I know that I cannot replace B. So it means I need to replace the elements other than B. So the number of elements other than B will be what? They will be window length minus count of B, right? If I can just remove the count of B from the window length, I will get how many characters there are that are not equal to the character that has the highest frequency. So here in this case, the window length is 1, 2, 3, 4, 5. 5 is the window length. If I remove the count of B, that is 3, I will get 2. So it means there are 2 characters that are not equal to the character with the highest frequency. It means if we can replace these 2 characters with the character of the highest frequency, we will have this particular window length valid, right? If I can just replace C by B and X by B, we will have a valid window. But how do we know that if we can actually replace them? And that is where this K will be helpful. So K will tell us if we can replace these characters. Since we only have 2 characters and the K is also 2, it means yes, we can perform 2 operations to replace 2 characters, right? So that means this 2 needs to be less than equal to K, because then only we can make this entire string a valid string. Otherwise, it will not be a valid string. So what this means is that this particular condition, window length minus the count of the maximum frequency element, should be less than equal to k. And if this is true, we know that the current window length or the current substring is a valid substring. And then what we can do is we can take the window length or the substring length and store it inside of a result variable. So we will have a result variable that is store the maximum substring length or window length. So it means each time we will find a valid substring, we will check if the current window length is greater than the length stored in the result variable. If it is greater than it, then we will simply store it here. We will update the result variable. Now getting the count of the character that has the maximum frequency will take order of 26 time complexity. Why? Because there are 26 alphabets in the English dictionary and we will have to check for each of them what is the value in the hash map. So it will take order of 26 and the entire algorithm will run in order of n time complexity. So it will take around order of 26 multiplied by n time complexity to go through the entire given string and find out the result. Now let's do a dry run and see how sliding window will help us solve this question. So first of all, both L and R pointer will be at the first index, that is 0, 1, 2, 3, 4, 5, 6. So both the pointers are on 0th index. Now we will check if the current substring, that is this particular A substring, is valid or not. So we will take the window length. So window length is right now 1 because there is only one character. So first of all, we will take this A and place it inside of the hash map. So A right now have a frequency of 1. Okay, and now we will take the window length of the current window, that is 1, because there is only one character in the window right now, and then we will minus or subtract the frequency of the element that have the highest count, which is currently only A. So 1 minus 1 equals to 0, and the key for us right now is suppose 3. Okay, so is 0 less than equal to 3? Yes, it is less than 3. So our current string A is valid. It means we will take the window length or the string length and we will compare it with the result. So currently result was 0 and now the window length is 1. So is 1 greater than 0? Well, yes, it is greater than 0. So we will replace 0 with 1 in the result. Now we will shift the R pointer to the next index, that is here. So R will be here. Now the window length is 2 because there are two characters and we have B again. So I will take the B and place it inside of this hash map. So B is occurring one time. Now we will take the current window length, that is 2, and subtract the highest frequency element from it. So the highest frequency is, well, just 1 in both the cases. So we will take the 1 and subtract it. And right now it will give us an answer of 1. What it is saying is that if we replace one element out of these A and B, we will have a string that will contain same element. So if I replace B with A, then I will have two A's in the string. Otherwise, if I replace A with B, then I will have two B's in the string. So now is 1 less than equal to K. So K is 3. So it means our current window is valid. We can turn every character same in this string. So now we will take the window length 2 and compare it with the result. Currently result is 1, which is less than the window length 2. So we will replace the 1 with 2. So result contains 2 now. So now we will take the right pointer and shift it again. So R will be here and the B is now increasing. So we will take the B and increase its frequency to 2 because there are 2 B's in the current string, this one. So now the window length is 3 and the maximum frequency of an element is 2 here, right? So we will subtract 2 from 3 and it will give us 1. Is 1 less than equal to K? It is, because K is 3. It means the current window or current substring is also valid. It means we will take the window length 3 and we will place it here in the result because 3 is greater than 2. So currently our answer is 3. Then we will take the R pointer, shift it again and we will be here. So we have a new C character. We will place it in the hash map. The frequency is going to be 1. The current maximum count is still 2 for the B. So we will take the current window length 4 because there are A, B, B and C. And we will subtract the maximum count, that is 2. So it will give us 2. And is this less than equal to K? Well, it is because K is 3. So right now this particular window length or this particular string is still valid. So we will take the 4 and we will just replace it here. So now our answer is 4. Now we will again shift the right pointer to the next element, that is X. So we have X, we will place it inside of the hash map right here. The frequency is going to be 1 and now the window length is 5 and the maximum count is still 2 for the B. So 5 minus 2 is equals to 3. Is this less than equal to 3? It is. It means we can take the 5 window length and place it here. We will cross the 4 and now the result is 5. Now we will again take the R, shift it to the next index, that is B. So the B will increase from 2 to 3 here. And now the maximum count is 3. And currently the window count is 6 because we have 6 characters in the window. So we will say 6 minus the maximum count 3 is equals to 3. Is this less than equal to K? It is, because K is 3. So it means this particular window length is also valid. It means we will take this 6 and place it right here in the result. Now we will move the R pointer again. We will be here. And this is the case where we might see some difference. So right now the window length is 7. Okay, we have a D character. The D will be placed here with the frequency of 1 and the maximum count is still 3. So 7 minus 3 is equals to 4. Is this less than equal to K? No, K is 3 and the current is 4. So it is not a valid string. It is not a valid string. And in this case, I will not place anything in the result. I will take this left pointer because R is no longer here. I will take the left pointer and I will shift it. So L will come here and then we will take this A and remove its frequency from the hash map. So earlier it was 1, now it is going to be 0. We are updating it. Now the window length is again 6. So 6 minus 3 equals to 3 less than equal to K. And so the window length 6 currently is valid, but it is already here in the result variable. So we will not update anything. But now R cannot be shifted to any other element because it doesn't exist. It means L will keep on shifting to the next indexes, the window length will keep on reducing, and we will keep on updating the result variable as we were doing. So at the end, 6 will be the maximum substring length that we can have, and that will be the answer. Now the current time complexity is order of 26 multiplied by n, and this n is coming from the sliding window technique because sliding window takes order of n to complete entire solution. But this 26 is coming from this hash map. In each of these iteration, we have to take the hash map and we have to find the element and its count. So we can find the maximum count that we can subtract from the window length. And this is taking order of 26 time complexity because there are 26 alphabets in the English language. So is there a way to get the time complexity even lower? There is a way we can get this entire thing done in order of n instead of 26. We can eliminate this order of 26 thing altogether. And we can do that by taking a variable maximum frequency and store the maximum frequency that we have encountered till now. So we will keep on updating this A, B, C and D. So each time we update it to a value that is greater than the maximum frequency that is currently stored, we will update the maximum frequency to this value. Okay, so this will represent the maximum frequency of a character in the current window. So it means in case in the future if B increments and it becomes 3, we will simply compare that to the maximum frequency and we will change from 2 to 3. And this is going to work fine because we are always going to get the access to the maximum frequency without actually going through this entire hash map. Each time we are just updating the hash map, we will also update the maximum frequency if we need to. Simple. But the place where it might break is when we are reducing the elements on the hash map. So suppose that the B is no longer in the window. So we will reduce it to 2. Now what do? Should we reduce the maximum frequency? I mean, logically, you should, right? I mean, if you are reducing the B to 2, you might think that you want to reduce the maximum frequency. But that is not really true. You don't need to reduce the maximum frequency because we have this particular condition that the window length minus maximum frequency should be less than equal to K. Now what we want to do is we want to get the maximum value possible for this particular expression. Basically we want to get K, to be honest. We want to make sure that we are able to utilize all of the K operation to get the maximum length substring. So how can we maximize this particular thing? Well, if we try to maximize the window length but reduce the maximum frequency, what will happen? We will easily surpass K. We will get a value greater than K, which will simply make the entire string invalid, right? It will make it invalid. But if we do the other way around, if we actually maximize this frequency and minimize this thing, what will happen? We will eventually get negative numbers, and negative numbers are not valid, right? Even though negative number is less than equal to K, but negative string doesn't exist, right? So what we need to do is we need to maximize both of these things. We somehow need to make sure that this is maximum and this is also maximum. So window length is going to get maximized automatically as we go through the sliding window. But this maximum frequency, this can increase and decrease based on what is happening in the hash map. But we know that we need to maximize the maximum frequency because our answer result will only change when our maximum frequency increases. So here you can see that as our maximum frequency in the hash map is increasing, the result is also actually increasing from 0 to 6. And as soon as we start decreasing the maximum frequency, the answer will again decrease to 5, 4, 3, 2, 1. So in order to get the maximum result, we need to make sure this frequency is going to be maximum. And so what this means is that we don't need to reduce the maximum frequency even after reducing the count from the hash map. Because if you reduce the count from hash map, you are going to get the older results, right? You're not going to get some new result, and the newest result is going to be the maximum result anyways. So we will anyways return that at the end of the day. So why not just use this particular maximum frequency throughout the entire execution? And if in the future some element actually surpasses the maximum frequency, we will simply update this maximum frequency and get a new result, right? And simply return that new maximum result. And in this particular solution, you will get the order of n time complexity. Why? Because you are not going through the entire hash map to find the maximum frequency. You are actually storing it right here in a variable. So that means this order of 26 will be eliminated and you will be only left with order of n. But getting to this particular order of n solution is kind of tricky and you might not be able to do it in an interview or in some kind of contest. And that's why this order of 26 multiplied by n is, to be honest, more intuitive to come in a pressure situation, because this is kind of a tricky thing. I was not able to figure this out order of n solution by myself. I had to look up online. So now let us look at the code for both of these solutions and then you can decide which one is your preference. So here is the order of 26 multiplied by n time complexity solution. Here we have the count hash map, then we have the result which is set to 0, then we have the left pointer set to 0, and now we are running a loop. Here we are using the r pointer as the right pointer. Now here we have the character at r index from the string s and we are trying to get its count. So if this character does not exist in the count, we will get a 0, otherwise we will get its count. And then we will increment its value and just store it in the count again. Now here's the condition for valid window. Now while this thing, the window length minus the maximum frequency is greater than k, while this thing is true, we are going to take the element at L index in the string, we will decrease its count from the hash map and we will increment the L pointer so that we will reach a valid window. And once we have found the valid window, we will simply update the result with the maximum of current window length and the originally stored value in the result. And once this entire loop runs, we will simply return the result. Now let us try to run this and see what happens. So yeah, it runs in 182 milliseconds and beats 23.27% solutions on Leetcode. Now let us look at the order of n time complexity solution. So in this solution, we have the count hash map, we have the result, we have the L pointer again, and we have the maximum frequency variable that will store the maximum frequency we have encountered till far. Now here we again have the for loop, where we are using the r pointer as the right pointer, and here we are updating the count of the element at the r index in the string. And here we are updating the maximum frequency if it needs to be updated. So we are going to take the maximum between the maximum frequency current value and the count for the current character at index r. Once it is updated, we will use the while loop to make sure that the current window is valid, and then we will simply update the result here. And once this entire for loop runs, we will have the result right here and we will simply return it. So now let us try to run this and see what happens. So yeah, our code runs in 119 milliseconds and beats 60.80% solutions on Leetcode. So it's a pretty efficient solution. So the time complexity is something that we have already discussed. It is either 26 multiplied by n or simply n. But the space complexity is going to be order of 26. Why? Because we are using a hash map and this hash map will store A to Z characters, which are basically 26 characters. So it means the size of the hash map can be at most 26. That's why we have order of 26. You can also consider it as order of 1 because at the end of the day, it is kind of a constant thing, right? So yeah, like the video, subscribe the channel. If you have some kind of question that you would like me to target or you have some kind of topic that you would like me to talk about, just let me know in the comments. Now we will meet in the next video. Till then, bye.